here's the solution to homework set number 8 for ECE 320. The first problem is DTL Logic. The starting point is to figure out which diodes are on or off, whether the transistors are on or off. So here I've got 5 volts trying to push current through 2 diodes. So the current will be 5 minus 1.4, 3.6 volts across 50K, gives you 72 microamps. That allows beta IB, allows 7 milliamps to flow. I'm only trying to push 5 volts over 2K, 2.5 milliamps through here. So this saturates. It makes it 0.2 volts. I need 1.4 volts to turn on these 2 diodes, making I4 equal to 0, making this transistor off. Then by voltage division, I get 50 over 50 plus 2 times 5 volts, 4.8 volts. So that's the first problem. If I simulate in Circuit Lab, I get almost the same answers. Again, the saturation voltage of 0.2 is ballpark, close to 0 but not quite 0. Circuit Lab says it's actually 0.06 volts saturated. Let's see. The 0.7 volt drop across the diode, again, is a ballpark. Circuit Lab says it'll actually be 4.4 volts, not 4.3 volts. Again, with Circuit Lab, the answers ought to be similar, but they will be different. Build in Lab, you'll get, again, similar answers, but slightly different. Problem 3 is TTL Logic. If I have a circuit on the left, I've got a path to ground from 5 volts going left. That tries to pull current also left, and there is no source of current, so IC equals 0, making this transistor off. When it's off, I get by voltage division 30 over 32 times 5, 4.6 volts. When the voltage over here is 5 volts, this is the easiest path to ground. And so this diode is turned on, 0.7. This diode is turned on. And this is actually an NPN transistor used backwards. It just has a lousy beta when used backwards. Gives you 5 minus 1.4 over 30K, 120 microamps. If beta is 3, then this current is 3 times that, 360 microamps. And the total current is then 480 microamps right here. Where the 480 comes into play is that tells you how much current you allow. Current IC is beta IB. This allows up to 48 milliamps to flow. I'm only trying to push 2.4, so beta IB is more than IC. This saturates, and you get 0.2 volts at the base, at the collector, ballpark. Simulate it, and you get pretty much the same answers. When the Q2 is turned off, look at B3, I get 4.68 volts. When Q is turned on, I get 0.2 volts, ballpark. For number 5, this is using DTL Logic to turn on and off the temperature alarm. In this case, when both inputs are 0, the current goes left, either to V1 or V2, I don't really care which. The net result is this is 0.7 volts. 0.7 isn't enough to turn on these 2 diodes. I need 1.4 volts to turn on those 2. I don't have it, so this turns off, and there's no current flow. When they're both 5 volts, now current flows to the right. I get 5 minus 1.4 volts over 1K, 3.6 milliamps. That allows beta IB, 360 milliamps to flow. I'm only trying to get 5 over 28, about 200 milliamps to flow, so this saturates. In Circuit Lab, I can check. When they're both 0 volts, I get V4 is 5 volts, there's no current flow. When they're both 5 volts, current goes right, this saturates, and now I do get current flow, V4 is 0.2 volts, ballpark, 0.241. And if you build it, here's the circuit that I built. Here's the 555 timer. Here is the comparator. One side goes to a thermistor and ground. That's right here, thermistor and ground. The other side is a voltage source. I did that with the potentiometer. 5 volts on one side, ground on the other. As I turn the pot, I can adjust the wiper voltage, anything between 0 and 5. That goes to the plus input. The output then goes to a diode. When this is 5 volts, it enables the pipe timer. When it's 0 volts, it turns it off. What it looks like, this is the voltage across the wiper. As I turn the potentiometer, I can adjust that voltage from 0 to 5 volts. And why is it not working? You can try that again. Here's the wiper. I can get anything between 5 volts and 0 volts when I adjust the wiper. If I set it up to turn on about at 2 volts, nice round number, I can then go over and look at the voltage across the thermistor. In there. Oh, baby dog. As I heat up the thermistor, the voltage should drop. That's what's being displayed, the voltage across the thermistor. When it drops below 2 volts, the speaker should turn on. So trying that. So 2 volts, it turned on. Let it cool down. As it cools down, the voltage goes up. 2 volts, it turns off. So that's homework set number 8.